In this question, we're going to use the table right here to identify various intervals on the domain where an x-intercept, y-intercept, relative minimum, and relative maximum might occur. We're not going to graph this function and check it out. We're just going to use this table. So to help us figure out where an x-intercept, or I should say what an x-intercept might look like on this table, let's use this coordinate system down here to review some information that we know about x-intercepts. Imagine if we had a line going like that, right? Well, how can we identify an x-intercept? Well, you might say, well, we know it's an x-intercept right here because it crosses our x-axis. Well, what else do we know about that x-intercept? And you could say, well, this x-intercept is going to have a y value of 0. And in this case, we don't know what that x is going to be because nothing's labeled, but we do know that the y has to be 0 because all my y values up here are positive, all my y values right here are negative, but right directly on my x axis right here, the y values are all going to be 0. So that's how we could identify an x-intercept. So for this particular x-intercept, it looks like our y values have to go from negative, and then it'll hit 0, and then the y value becomes positive. And does that happen at all down here with our y values? And it does. We went from negative 12 here to positive 1 here. So somehow it had to cross the x-axis because our y values here change sign. So just like here we went from negative to positive, we went from negative 12 to positive 1. So it had to cross that x-axis. And our question is asking us to identify various intervals on the domain. So I'm going to write my interval as being from negative 1 to 0. That's where one x-intercept happens. And we're going to continue looking at our y values. So from right here we have a y of 1, and then it gets down to 0, and that actually is a x-intercept, right? Because we said that our x-intercepts happen when y is 0, and right here our y is 0. So I don't have to write an interval for that one. We could just write our actual point. So 1 comma 0 is going to be an actual x-intercept. So then our graph would cross y equals 0, and then it goes down to negative 9, and then negative 20, negative 27, negative 24, negative 5, and then here's another sign change. So it went from our negative values somewhere down here to positive values all the way up to a positive 36. So that happened between 6 and 7. That's the interval of the domain that we're going to use. So somewhere between 6 and 7, we know that our graph crosses the x-axis because our sign changed for our y. So that was x-intercepts. Now we want to take a look at our y-intercepts. So just like x-intercepts happen when y equals 0, our y-intercepts happen when x will be 0. So does our x equal 0 anywhere here on our table? It does right here. So then our y-intercept is going to be a point of 0, 1. And just like we realized that x-intercepts happen when the sign of the y values change from negative to positive or positive to negative, we could use that same idea for y-intercepts. And we realize that we change from negative 1 here to 0 and then to positive 1. So there's going to be a y-intercept between negative 1 and 1. But again, we have 0 here, so we know that it specifically happened at 0, 1. Now let's take a look at what happens whenever we have a relative minimum. So I have some blue material right here where we have a u, and that's what a minimum would look like. And I called out some made up y values here. And as you can see, as we go from left to right, our y values decrease. So we start off here at y equals 5, and then y equals 4, and then y equals 3, but all of a sudden it changes direction and they start to increase again. So they went from decreasing and then increasing. That's what represents a relative minimum. So our y values are going to be decreasing, and then all of a sudden they change direction, they start going up again. That's going to represent that minimum shape. We're going to use that same idea to identify a maximum. So our maximum is not going to be a u, it's going to be a u that's flipped. And I called out some made up y values here as well. We went from -5 up to -4 and then up to -3. So we're increasing, and then all of a sudden we went from -3 down to -4 down to -5. So then we start to decrease. So we go from increasing to decreasing, and that represents our maximum shape. So it's all about the change in direction of our y values. So let's look at our table here, and we want to follow the direction of our y values. So from -45 to -12, we're increasing. So I'm going to put up an up arrow there, right? We're increasing y values. From -12 to 1, we're increasing as well. From 1 to 0, it looks like we decreased, right? So something's going to happen there, all right? I'm going to keep going. So 0 down to -9, we're decreasing. From -9 to -20, decreasing. We're going down to -27 again. But from -27 to -24, we change direction and we're increasing, okay? Then from -24, we go up to -5 and then up to +36. So back to this area. From -12 to 1, we went up, but then from 1 to 0, we went down. So this right here is going to represent a relative maximum, because just like right here, we were going up and then we went down. That's going to be that maximum shape. And then we want to figure out the domain, and that's going to be from -1 to +1. Somewhere between those two x values, that's where that relative maximum happens. The other area where we changed direction was right around here. We went from -20 down to -27, and that was all good. But from -27 to -24, we went back up. So this is going to be a change in direction that represents a relative minimum, because we were going downwards, and then all of a sudden we started to go back up, which would be this figure right here. And that interval is going to be from 3 to 5. So from x equals 3 to somewhere, from x equals 3 to x equals 5, somewhere in that interval, the domain is a relative minimum. So those are going to be all the key features that we could identify from the table. So I know that we said we weren't going to graph our function, but let's go ahead and do that and see if we're right here. So I'm going to use Desmos.com to graph that function, and here it is in purple. And let's go back to my paper here. We wanted to say, we were saying that an x-intercept happens between -1 and 0, and then also between 6 and 7. And then it actually happened at exactly this point, 1, 0. So -1 to 0. Does it happen? Yeah. From -1 to 0, we have an x-intercept right there. And then over here, from 6 to 7, we have an x-intercept. And then this was our exact x-intercept at 1, 0. So we're good with our x-intercepts in their predictions. We also said that there is going to be a y-intercept at 0, 1. So I jump back to my graph here, and my y-intercept right there is 0, 1. So that was good. We were saying that we have a relative maximum that happens anywhere between -1 and 1 for my x values. So I go back to my graph, and between x is -1 to +1, yep, we have an upside down u that happens right here. So that would make sense with our prediction. And then lastly, we said there was a relative minimum that was happening between 3 and 5. So let's see. Here's x equals 3 and x equals 5. So we got to move our graph down and let's see. Move it down, 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 all the way down. And here is our u. This is going to be a relative minimum. And our x value is about 4.2. And sure enough, that's between x equals 3 and x equals 5. So we're good with that prediction as well. So everything seems to check out.